All right, this is workbook page 11. Practice A, similar figures. Which triangles are similar to triangle ABC? So first of all, you need to know which one is triangle ABC. This is triangle ABC. So we're going to compare these three on the right to the original ABC and see if they are similar. So here's where those two definitions for similar come into play. Are the corresponding angles congruent? All right, let's put that in regular words. Corresponding, meaning matching. Are the matching angles congruent? Congruent means the same. So matching angles. If I'm talking about angle C, what does that match up with on the small triangle? It would match up with angle T. Are the corresponding angles congruent? 28 degrees? 28 degrees. Yes. But sometimes the orientation is different, meaning it's turned differently. So angle C from the original doesn't match up with M. It actually would be K. 28, 28. It looks like that's probably going to work, but you have to check all the angles. Well, with a triangle, they don't have to be in the same order. They just have to be the same amount. So what we're looking for is a 28, a 110, and a 42 in any order. So 28, 110, 42. This one's perfect. It's even in the right order. So this passes number one. The corresponding angles are congruent. That's true. We have to check to see if the sides are proportional, because that's rule number 2. So that's where the proportion comes in that we were working on. There are 3 side lengths in this triangle. They gave us 3 numbers. We only need 2 of them to fill in the 2 blanks on the top of the proportion. You can use 6 and 14, 14 and 10, 10 and 6, it doesn't matter. I'm just going to use 10 and 6 since they're both at the top and they kind of line up. So 10 and 6. Now, what does that correspond with over here? 10 matches 5, and 6 matches up with 3. So now we cross multiply. So 10 times 3 is 30, and 5 times 6 is 30. That's a match. That means that this is a similar triangle. So now we try the next triangle. We compare it to the original. We're still using 10 and 6 from the original. So that's going to match up with 12. Oh, sorry, excuse me. I don't even have to do that. I forgot step 1. Step 1, check the angles. Is it 28, 110, or 42 in any combination? We have the 42. Do we have the 110 and the 28? No. So we don't even have to check the side lengths on that one. It doesn't match the first rule. Third triangle. Check your corresponding angles. I'm looking for a 28, a 110, and a 42. 28, 110, 42. Got those. So number 1 works. Now I've got to check the proportions on it. So I'm using 10 and 6. So let's look at side 10. We would call that side AC. You've got to figure out what does that match up with this triangle. Well, AC would be the same side as JK. So it is also 10. And then side 6, right here, would match up with this side. That's 6. 10 times 6 is 60. 10 times 6 is 60. All right, so we're going to select that one too. Not only is this one similar, it's exactly the same. It's a mirror image. So this one's congruent. It's 100% the same. It's turned different, but it's the same shape and size. So it's also congruent. All right, number 2. Which rectangles are similar to RSTU? RSTU. So we're going to compare these. Now, it did not give us any angle measurements. The reason is it tells you that they are rectangles. That means that every corner is a 90. So all of these passed rule number 1. We've got to check the proportions though. So we know we have these 2 numbers. That's the only 2 numbers we have to use. So we're definitely going to use 2 and 6. So 2 corresponds to 3. 6 will correspond with 8. So we cross multiply. 2 times 8 is 16. 3 times 6 is 18. That's not a match. That's a no. That means this is a no. That's not a similar rectangle. I hope I said rectangle on this. If I said triangle, I apologize. I hope I said rectangle. All right. Next one. All right, still using 2 and 6. And 2 corresponds to the 1. 6 corresponds to the 3. We cross multiply 2 times 3. That's 6 equals 1 times 6 is 6. 6 equals 6. That is true. That's a similar rectangle. All right, let's try this last one. 2 and 6 matches up with 3 and 9. 2 times 9, 18. 3 times 6, 18. That's also a similar triangle. Say it again, similar rectangle. It's the end of the day, I'm on planning, I've already taught 5 classes. Getting a little tired. Similar rectangle. All right. Number 3 is a simple question. It says a room is 36 feet long and 18 feet wide. What is the length to width ratio? So that would be 36 to 18. It could also be written this way, 36 to 18, 36 to 18, and it can even be simplified as a 2-to-1 ratio. Okay? Number 4. Number 4 is where we start to draw a little bit. Please, please, please draw to help yourself, because if I read this, it's going to sound like that old Charlie Brown. So listen to this. An isosceles triangle has a base of 8 inches and legs measuring 12 inches. How wide is the base of a similar triangle with legs measuring 36 inches? And then we could just have a staring contest, because it sounds like wah, 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 okay? Let's break that down piece by piece and let's draw a picture. It will be very helpful. If you don't know what isosceles means, that's okay. It's not required to know what an isosceles is to solve this problem. I'm willing to bet that you know what a triangle is. So I'm going to draw a triangle, and I'm going to leave myself space to put some numbers around it. So a triangle has a base of 8. Well, probably going to know that the base is down here at the bottom, and that's an 8. Continue to read. And legs, and that's plural with an S, so that means more than one of them, and in this case, 2. 2 legs measuring 12 inches. That means that the 2 sides right here have to be 12 inches, and that is the definition of isosceles. Isosceles means that the 2 legs of the triangle are the same length. Okay? Continue to read. How wide is the base of a similar triangle? So right there, that tells me I need to draw a similar triangle. So there's my next one. And it says with the legs measuring 36 inches. So that means that these 2 legs are 36. And if we go back, it said, how wide is the base? There's our question. How wide is the base? That's the unknown. That's where we're going to put our variable. All right, so we've got our similar figure problem. We now have our picture just like we did before. And we've got to choose 2 numbers from the first shape to use. Now, it is important which ones we choose this time, because if you choose 12 and 12, you will not figure out what x is. Some people like to go ahead and start with x. Some people just know that, hey, I've got to use something that corresponds to x. So we can't use 12 and 12. We can use 8 in either one of the 2 12s. So definitely going to use 8, and I think I'll just use this 12 right here. So I'm going to use 8 and 12 across the top. Remember, one shape fills in the top, the second shape fills in the bottom. Well, 8 corresponds to x. That's a match. 12 corresponds to 36. That's a match. Now I'll cross multiply. 8 times 36, and I cannot remember what 8 times 36 was, so I'm going to look. I believe it's 288. Let's see, yep, 288. 288 equals 12x. Okay, divide both sides by 12. And we find that 24 equals x. So the true answer to this problem is 24 inches. 24 inches would be the exact answer. All right, number 5, a photo that is 8 inches wide and 12 inches long. What shape are you thinking? 8 wide, 12 long. It's a photo. You've seen a photo before. Rectangle. So 8 by 12, okay? I know I'm going to have another one because it says right here, it says they're going to enlarge it to a poster. Same shape, just going to make it larger. Now I know mine's not any larger, but that's okay. We're going to use numbers. So enlarge it to a poster. If the width is enlarged to 24, so I've got to figure out, does 24 go at the bottom or on the side? I need to go back to the original. 8 inches wide. That was the short side. Wide is the short side. That means 24 corresponds to 8. So 24 needs to be in the same position as the 8. They're both the short side. They're the width. And it says, what is the length of the poster? Well, I don't know. I'm going to put an X right there. I don't know the length. So proportion time, 12 and 8 on top, X and 24 on the bottom. 12 times 24 is 288 again. 8x, divide both sides by 8, and we find that the answer is 36. 36 equals x, in this case 36 inches. 36 inches. All right. Problem number 6. Clyde makes a copy of an 8 by 10 inch photo, reducing it to 3/4 of its size. What are the dimensions of the new photo? This is better solved as a dilation. Okay, dilation is in Unit 1. That's the unit we're in. I may have shown it to you in class. I had the plastic ball that could expand and contract. So that's a dilation. Same shape, different size. So the easiest way to solve this is to use the scale factor. This is the scale factor. And when using a scale factor, you always multiply. So we simply want to do 8 times 3/4, and that equals 6. And we'll do 10 times 3/4, which equals 7.5. And that is the new dimensions of the photo, okay? It would be 6 by 7.5 inches. I should have put inches in here. See if I can squeeze that in. There you go. Just like they wrote the original. They did 8 inches by 10 inches. 6 by 7.5. All right, last one. Problem 7. It's about the White House. Don't know if you've ever been to the White House. Pretty neat place. Been there, I've been inside of it 3 times. I've been in front of it a bunch of times. Probably 10 times. Front of it, behind it, beside it, all around it. All right. The White House, built in 1792, is the oldest federal building in Washington, D.C. The building has undergone extensive remodeling over the years. Nothing I've read so far pertains really to this question. We didn't need any of that. It's just fluff. The main building is 4 stories high and is about, here's where we get to something we need. It's about 170 feet long by 85 feet wide. So we're going to use a rectangle to represent the White House. The long side is 170. The short side is 85. If a replica is like a model of it. If a replica of the White House were made with a length of 4 feet, all right, so we've got another rectangle. We've got to figure out where we're going to use this 4 feet. Is it going to be the long side or the short side? Well, if you look back, the word is length. That corresponds to the word long. So 4 is going to be used in the same place we used 170. So that's going to be here. What would the width of the replica be? This is the width. So we're going to do our proportion. We'll use 85 and 170 up here. 85 and 170. And then 85 corresponds to x. 170 corresponds to 4. 85 times 4 is 340. 170x. Divide both sides by 170. We get 2 is equal to x. So the actual answer is 2 feet. 2 feet would be the final answer. All right, that's it for page 11.